Okay, we have reached the last part of Chapter 3. Last part of Chapter 3 is solving conversion problems. Again, this is going to be really important for us because we're going to use the techniques that we learn here in many different ways for the rest of this year. One of the important things about this is that you are definitely going to need use of a calculator. So you should definitely have a calculator nearby with you, scientific for sure. And you're going to need to kind of follow along with the notes because we're going to do a number of practice versions of this problem. So solving conversion problems requires some steps that you've got to follow. Probably a lot of these steps you already do, but I want to make sure that everybody is doing all of these steps when you have to solve any kind of mathematical problem in this class. First, read the problem. Seems simple, but you got to read the problem to make sure that you know what you're doing, right? And then I'd like you to write out your knowns and your unknowns. When you read through the problem, there's really only a few things in the problem that are actually important for us to know. And there's only usually one thing that we don't know and that we need to find. All of the other words that are in the problem are generally just extra stuff that we don't need. So I want you to basically strip down the problem into its basics. What do you know from the problem? What do you not know from the problem? That's it. Then once you have that, you generally can start to get an idea of how do you take those knowns and find what is unknown. It's one of two ways. You're either going to know some kind of formula. For instance, you've memorized the formula for density. So density is mass divided by volume. So if they gave you mass and volume and they ask you to solve for density, then obviously you would just use that formula that you memorized. But sometimes you won't have a formula to use, and you'll just need to convert units of one thing to units of another thing. That's when we use something called dimensional analysis, and we're going to get into that. You need to show your work. That's a really important part of this. I've told you all along that I want you to use a calculator when you do math in here, and that's not changing. I certainly want you to use a calculator at all times. Okay, it's just a much better way than having to do it in your head. But you still have to show me how you figured it out. You can't magically type it into your calculator, never show me anything, and then just put an answer down on a page. Because in the end, I don't know how you really found it. And even if it's right, how do I know you really did it? And so showing your work has multiple reasons, but the biggest one is I need to be able to follow along with what's going on in your head. How did you figure out how to do it? What was your plan? You need to make sure that your final answer has units on it. Remember, these are measurements we're working with in this class. There are no naked numbers. That's gross and illegal in most states. Okay? You need to make sure your final answer makes sense. It's also a big thing that a lot of people just don't even think about. When you get done, make sure it makes sense. If you get an answer that seems absolutely ridiculous, it probably is, and that probably means you made a mistake. And finally, when you're done, circle your final answer. It makes it easy to kind of see quickly what the final answer was, and then we can kind of work back from there to see what your work was, especially if it's wrong. And we need to check and see where the mistake was in your work. All right, so we're going to do, like I said, some examples. And we're going to start with something that I would consider a really simple problem. So this problem says an object has a mass of 2.5 kilograms and has a volume of 0.10 cubic meters. What is the object's density? So first thing, we've read it. Now we have to go through and write down knowns and unknowns. What are the important things in this and what is not important? I think you found right away what the important things are. They told us what the mass is and what the volume is. Now, we don't need all of these other words, so let's just kind of strip out the important stuff and write it in a small table here. So the mass, which we're going to abbreviate as M, the mass was 2.5 kilograms. And volume, which we'll abbreviate V, the volume was 0.10 cubic meters. Don't forget, the 0 is important here, right? The significant figure rules say if there is a decimal point, then zeros at the end have to count. So you can't just round that off. Now, that's what they told us we know. What is it that we're looking for? What's our unknown? Well, they're asking for what's the object's density. So D equals, and I don't know yet. That's going to be our unknown. Now, we write all of this down, knowns and unknowns, because at this point, I could completely erase all of these words up here, and you'd still know what we're doing. That's the whole point of knowns and unknowns. All right, now we have mass and we have volume. We're trying to find density. Already your brain is probably thinking, oh, I know how to solve this problem, right? So write it down. Don't keep it in your brain. Don't have your brain go, oh, I know how to do this, and then suddenly it's a secret and nobody knows what you're doing. Write it down. You know that you would use the formula, density equals mass divided by volume. In fact, write it down under knowns because you know it. So it is a known. All right, so density equals mass divided by volume. My final step here is to go through and show my work. So I actually have to plug in the numbers. 2.5 kilograms has to be plugged in for M. 0.10 cubic meters has to be plugged in for V. So I have to show that. So write it down. Density equals 2.5 kilograms divided by 0.10 cubic meters. So this is showing your work. This is what I mean by showing your work. Now, to do the actual math, you can do that part in your calculator. So now you can pull your calculator out and you can hit 2.5 divided by 0.1. And so your calculator is then going to tell you the answer is 25. And then you have to do a little evaluation of this. First, put your units in. Kilograms was on top, cubic meters was on the bottom. So this is kilograms per cubic meter. So that's my unit. Second, I have to evaluate for significant figures. I just divided two measurements. The rule says when I divide measurements, I go by the least number of significant figures. So 2.5 had two significant figures in it. 0.10 had two significant figures in it. Does my answer have two? Yes. So that's good. All right, so we've done everything except for, what's the last thing? Oh yeah, circle our answer. All right? That's what we mean by using this step-by-step method to solve a problem. No matter how simple the problem is. Now, this was a really simple problem. It didn't take a whole lot because they gave you the mass right off the bat. They gave you the volume. They asked you for density. And that's something that's pretty easy to find. So it didn't take much to solve this problem. Let's do a version that's just a little tiny bit harder. Not a lot, but the best way to learn how to do this is to try it on your own. So once again, I want you to hit pause. Try to do this problem on your paper without me. List your knowns, list your unknowns, figure out what formula you're going to use, show your work, come up with the answer, check your answer, and circle it. Do all of that, and then come back, and I'll show you how I would do it. Okay. You've done that, you've paused, you've tried it out on your own, because again, that's much better than just watching me solve problem after problem. That isn't going to help you in the long run. So we have to list our knowns and unknowns first from this problem. So this problem says that the density of aluminum is 2.7 grams per milliliter. So that means they told us the density this time. So obviously that's one of the knowns we should write. It also said that the mass was 8.1 grams. So that also seems like a really important known. So we should write that one down. Now, what are they asking us to find? Well, this time they're saying, what is the volume? So volume is the unknown this time. Okay, so they gave us density, they gave us mass, and we're trying to solve for volume. Can we still use this same formula from up here, density equals mass divided by volume? Well, yeah, but we're going to have to rearrange it a little bit because we need to solve for V, not D. We need V by itself and isolate it. So if we take that formula, so I'm going to write it again down here, but we rearrange it. So this time I'm going to have V on its own and D. So V and D, by the way, if you know this little trick from algebra, V and D can just simply be switched. If D is on the top end on one side of the equal sign and V is on the bottom of the other side of the equal sign, you can simply switch those. So in other words, volume equals mass divided by density. Well, now that I know what formula I'm using, now I can just fill in the numbers. What is M? It's 8.1 grams. What is D? It's 2.7 grams per milliliter. So 8.1 grams goes on top, 2.7 grams per milliliter goes on the bottom. And now I know what to do with my calculator. I need to take 8.1 and I need to divide it by 2.7. When you do that, your calculator gives you an answer of 3. It doesn't say 3.0 on your calculator, it just says 3. But when you evaluate this answer, you look at this for significant figures. You realize that this number had 2, this number had 2, therefore your answer also has to have 2. So you had to put 3.0 so that it has 2 significant figures. The other thing we have to do is look at the units. Notice that the units on top were grams. The units on the bottoms were grams per milliliter. Well, what's going to happen to the grams? They're going to cancel. What are you going to be left with? Just milliliters. And so that's our final answer. Okay, so at this point, we have done 2 problems, and both of these problems have had a formula to use. They were both density type problems, so we used the density formula to solve for them. It's not always going to be that way. It's not always going to be a problem in which they're just going to kind of lead you right into something you already know. So what if we need to solve a problem that doesn't have a formula? We're going to use the units to guide our work. And we're going to use something called conversion factors. So a conversion factor is 2 units that are equal to each other. Like, for instance, I know there's 12 inches in a foot. So if I wrote 12 inches over 1 foot, that's known as a conversion factor. I could also write it the other way. 1 foot is 12 inches. It means the same thing. Or I could say there's 16 ounces in a pound. Or 1 pound is 16 ounces. Those are conversion factors that allows me to change 1 unit, like feet, into inches, or inches into feet. So we're going to use these conversion factors in a guided way to help us get from one unit to another. And it's a process called dimensional analysis. But really, it's just a process in which we're going to use units to guide us through the work. So again, we got to do an example to show how this is going to happen. So let's do what I would consider, again, a simple problem to start with. And then we'll get a little bit harder as we go. So how many seconds are there in 24 hours? Now, again, we have a known and an unknown here, right? The known is the time. The time is 24 hours. But the unknown is also time. It just happens to be a different unit. So they want you to take time that's 24 hours and change it into time in seconds instead. So you can see right away, we don't have a formula to change time into time. But we need a way to change hours into seconds. That's what dimensional analysis is for. So the way that we do this, and I'm going to handwrite this to begin with, and then I'll clean it up when we're done. The way we're going to do this is we always start with the given amount. And they're always going to be a given amount in the problem. In this case, there's 24 hours. So we're going to start by writing 24 hours at the beginning of this problem. By the way, hours can be abbreviated all the way as just H. And then we're going to start multiplying by conversion factors. Now, this means that you're going to have to figure out what units you need to convert into to get to your final answer. I'm guessing that most of you don't have any clue how many seconds are in an hour. It's not something that most people just have in their brain. And that's fine. You don't need to know that. But I bet you do know how many seconds are in a minute. And you probably also know how many minutes are in an hour. So we can use these conversion factors to help us. So let me show you how this is going to work. This is how it's going to lead us. So we started with 24 hours. So obviously the unit hours is what we need to get rid of. So the bottom of my first conversion factor, I'm going to put the same unit that I started with because I want it to cancel. So I'm going to put an H down here because I want hours to go away. Normally, the unit that I would put on top would be the unit that I'm looking for, except that would require me to know how many seconds are in an hour. I don't know that off the top of my head. Most people don't. So let's figure out how many minutes are in an hour, right? That's something that's obvious to everyone. There are 60 minutes in 1 hour. Okay, so I have conversion factor there. I have two units that are the same. 60 minutes is the same as 1 hour. I have hours on the bottom simply because I need hours to cancel. Now, I'm not done yet because all I've done is change this into minutes, and I need to get to seconds. So now I'm going to multiply by another conversion factor. The next conversion factor tells me that I need to get rid of minutes. So minutes is now going to go on the bottom of my next conversion factor. Well, can I change minutes into seconds? Sure, everyone knows that. There's 60 seconds in 1 minute. Now again, I have a conversion factor. There's the units that are the same. 60 seconds is the same as 1 minute. And I put minutes on the bottom because minutes was on the top over here, and I need the unit minutes to go away and to cancel. When I'm done with this setup, with this work that I'm showing, I should only have one unit left, and that is the unit I'm looking for, which is seconds. So what is this telling me now? Well, on my calculator, this tells me I need to take 24 times 60 times 60. Technically, it's also saying I should divide by 1 and then divide by 1, but I don't have to divide by 1. That means the same thing. So 24 times 60 is what you're looking for. Now, I'm going to replace this with something that's much neater. All right. So there's my conversion factors. I started with 24 hours. I took hours and changed it into minutes. I then changed minutes into seconds. And so I took 24 times 60 times 60. If you do that on your calculator is going to tell you that the answer is 86,400 seconds, or 86,400. It's not even going to tell you seconds. That you can figure out for yourself. But there's a couple of problems with 86,400. Okay? First off, how many significant figures are in the number 24? Well, it's only 2. So how many can be in your final answer? Well, only 2. So far, that's already 3 that's in this answer. So that's not going to help us. Plus, we have one other problem with this answer, and that is the rule in this class. If the answer is greater than 1,000 or less than 1,000th, I have to write it in scientific notation. So not only is this the wrong number of significant figures, it is written too big, and it needs to be written in scientific notation. So first off, let's move the decimal point over. So if I take the decimal point, which is down here, and I move it over 1, 2, 3, 4 spots, that'll help. And then I need to round it off because I can only have 2 significant figures. So I'm going to drop the 4 off. And so finally, our answer would be 8.6 times 10 to the 4th seconds. All right, so let's just review this real quick. So we still had to write down knowns and unknowns from the problem. But we're going to take that one known, and that's generally what you're going to get in a lot of these problems. You're going to have one known. That's your given that you start with the problem. And then we're going to simply multiply so that our units are going to cancel. So if I start with hours, hours has to go on the bottom. If this were, I don't know, kilograms, then kilograms would have gone on the bottom. If this were moles, then moles would have gone on the bottom. Whatever the unit was, that's the unit that would have then gone on the bottom, so it canceled. And then I would have to convert that into something. In this case, I had to figure it out. They didn't tell me how to do it. I had to figure out what units to go to. All right, let's try another one. Again, we're going to step up the complexity just a little bit. So this is just a little bit harder than the last one. This time they said the density of gold is 19.3 grams per milliliter. What is gold's density in decigrams per liter? So at first, this looks like it's going to be a density problem. But if you write down your knowns and your unknowns, you'll quickly see that it's not a typical density problem. So what's the known? Well, the density of gold is 19.3 grams per milliliter. What is unknown? We're still looking for density. We're just looking for it in different units. So we don't have a formula to change density into density. That doesn't make any sense. We're just converting the units of density into new units of density, from grams per milliliter to decigrams per liter. So once again, I need to figure out what are the conversion factors to take grams and change it into decigrams and milliliters into liters, right? So I have two conversions that are going to happen in this problem. And all of these units are metric units, right? Deci and milli, these are all metric units. Well, anytime you have metric units and you need to do a conversion, we have to remember King Henry died by drinking chocolate milk. And if I remember that, then I can figure out how many decigrams are in a gram or how many milliliters are in a liter, because I can just use this and move my my decimal point around. So let's start with grams and decigrams. I'm going to need a way of changing grams into decigrams or decigrams into grams, however you want to think of it. Well, where's deci on here? Well, that's right here. So if I want to change 1 gram, which is a base unit, right, to decigrams, what happens to my decimal point? It has to move over 1. So how many is that? 10. So the first thing that I know, and I'll write it under knowns, first thing that I know is that 1 gram is 10 decigrams. That's going to be important. What's the other thing that's important? Well, I need to go from milliliters to liters. So again, where is liters on here? Well, liters would be at base. So if I want to go to milliliters, how many places do I have to go to get to milli? 1, 2, 3 places to the right. So I have to take 1 and put 3 zeros after it. So how many milliliters is that? That's 1,000. So there are 1,000 milliliters in a liter. All right, I think that's everything that I would need, right? This allows me to go from grams to decigrams. This allows me to go from milliliters to liters. That's everything I need. But now we got to set it up so that the units cancel. First step in these kind of problems is to take the given amount from the problem and start with that. So the first thing that we're going to do is we're going to write out that known. Now, one thing that I want you to make sure you're doing is anytime they write a unit like this in the problem, they're really telling you a fraction, except that it's really hard to type fractions. So people over the years have used that slash. But really what that is a fraction. So anytime you see something per something else, like that slash, you really should write it as something over something else. That's a fraction. So 19.3 grams over 1 milliliter is really what that means. And the reason we do that is because now it's going to be easy to see how to cancel out our units. So what unit should we cancel out first, grams or milliliters? We have to cancel both of them out. It doesn't really matter which one we start with. Let's start with grams. Since grams is on the top here, when I go to multiply by my next conversion factor, where should grams go? It should go on the bottom, right? So that means grams should go on the bottom. What should I change grams into? Well, I'm looking for decigrams. So I already have a conversion factor over here, so I might as well use it. So I want to go from grams to decigrams. Well, there's 1 gram for every 10 decigrams. That's what my conversion factor over here says, so that's what I'm going to use it over here as. But I had to put grams on the bottom because I wanted grams to cancel. All right, so far so good, but I still have milliliters, and I don't want them. I want them as liters. So let's keep going. Next conversion factor. How am I going to get rid of milliliters? Well, milliliters is technically on the bottom. If it's on the bottom, how do I cancel it? I have to put that unit on the top of this conversion factor. Here and here, they'll cancel. What can I change milliliters into? Well, I already figured it out. I need to change it into liters. And notice I wanted liters on the bottom. It's going to end up being on the bottom. So milliliters is going to cancel. How many milliliters in a liter? We already figured this out earlier. It's 1,000 milliliters in a liter. All right, let's look at and see what happened. Grams canceled. Milliliters canceled. I'm left with dg on the top, and I'm left with L on the bottom. So decigrams over liters. Well, that's what I wanted. Perfect. So what is this telling us to do mathematically? 19.3 times 10 times 1,000. Divided by 1, divided by 1, divided by 1, but I don't have to do all the ones. So that's your job. Plug that into your calculator. What do you get? While you're doing that, I'm going to erase a few things. Okay, so you've done that on your calculator. Show off this excellent handwriting of mine. So your calculator probably told you this is your answer. It says, oh, your answer is 193,000. Once again, we have a problem with that. Right? Significant figures wise, it works. Because we had 3 significant figures in our known and our given in our problem, and this is also 3 significant figures. Because there's no decimal point right now, so these zeros don't count. So that's all right. But 193,000 should be written in scientific notation. It's way too big to be written that way. So we need to take our decimal point. We need to move it over 3, 4, 5 places, right? So we should be really writing this as 1.93 times 10 to the 5th decigrams per liter. And don't forget, last thing, circle your final answer. All right, we're going to do one more, but this time you need to focus and try to do one on your own. Just like we did here, there's going to be another problem just like it. A car is traveling 90 kilometers per hour. What is its speed in miles per minute? And I've also given you a little hint. 1 kilometer is the same thing as 0.62 miles. Pause here. Follow along with what we've been doing. Write knowns, unknowns, figure out your conversion factors, make sure units are canceling as you set up your problem, and then see if you can come up with the right answer, and then come back and check. All right, hopefully you had a chance to try this out. Let's write out what we know. Well, we know that the speed of the car is originally 90.0 kilometers per hour. I also know something else, right? I also know this, so we'll come back to that in a second. What's my unknown? What are they trying to find? Well, we're still trying to find speed. We just want to convert the units into miles per minute instead of kilometers per hour. By the way, miles has to be abbreviated at least MI. because if you leave it as M, then it looks like meters, and we don't want to get it confused. And then minutes would have to go at least M-I-N. If you just leave it as M-I, that's also confusing with miles. So just some ideas on abbreviating things. So anyway, we're going from kilometers per hour to miles per minute. So I need to go from kilometers to miles. Oh, look, they already gave us one of those conversion factors. But write a conversion factor like a fraction. Don't write it with an equal sign. Write it as a fraction. 1 kilometer is the same as 0.62 miles. Write them one over the other. That's how we're going to use it. What else do we need to know? Well, I have to go from hours to minutes. You know how to go from hours to minutes? Yeah, I hope you do. Right, there's 60 minutes in an hour. All right, so let's set this up. We're going to start with our given. The given is 90.0 kilometers per hour. Remember what per means, this slash. This is technically a fraction. Where does hours technically go? It goes on the bottom of the fraction. So write it like this. Do not write it like this in your problem. Otherwise, you'll think that kilometers and hours are both on the top. And they're not. Hours is on the bottom. All right, next, what should we cancel out first? Once again, it doesn't matter. Eventually, kilometers and hours are both going to have to cancel in this problem. Let's start with kilometers. So, kilometers would then have to go on the bottom. Miles would have to go on the top. Why? Because we want kilometers to cancel. One on the top, one on the bottom. They would cancel. All right, now we need hours to cancel. So on this next conversion factor, where is hours going to have to go? The unit hours will have to go on the top to cancel, right? And so hours goes on the top. That means minutes ended up on the bottom, which is good because we wanted miles over minutes. So miles over minutes. That works out pretty well. Once you get the units settled, then it's just a matter of looking at the numbers that are left and figuring out, do you have to multiply or divide them? If they're on the top, you multiply. So 90 times 0.62. If it's on the bottom, you divide by it. So 90 times 0.62 divided by 60. So once again, make sure you can do that on your calculator. Your calculator is going to tell you that the answer is 0.93. But 0.93 is not enough significant figures. 90.0, since there's a decimal point here, the 0 counts. So this is 3 significant figures. So my answer has to be 3 significant figures. So I had to put the 0 in there. And don't forget, circle your answer. All right, so that's using conversion factors to do dimensional analysis. That's the kind of problem that we're actually going to do quite often this year. And so you need to get comfortable with doing these types. And the only way to get comfortable with them is to do more and more of them. So you're going to have some in your homework problems that you're going to have to work with. Ask questions if you do not understand.